Okay, so in this video, we're going to work on adjusting our input so that it's based on the camera's orientation instead of the world orientation. And so to get a better idea of what that means, we should check out this button in the Unity editor, the toggle tool handle rotation. If you have this on global and you select the move tool and you click your player, you will be able to see the handles of the move tool face the same direction as the world orientation. So the scene widget here, or the scene gizmo, I think is what they call this, it shows you the world orientation, kind of like a compass. You could think of these almost as cardinal directions. So like the Z, the blue positive Z is the forward direction of the world. You could almost think of that as like north. And the right world orientation, the red direction on the x-axis here, could be like east, right? So if we look at the top-down view, and we can go to orthographic, you can see pretty clearly, north, east, right? Now, right now, no matter how I rotate my player, so I'll just drag his Y rotation value here, and you can't really even tell that he's rotating because the move tool is always facing the world forward. But if I switch this from global to local and I start rotating my player, you'll notice how the move tool handles line up with the player's local orientation. So this is the player's forward now. He's sort of turned to the left, but the world forward is still straight north. Now, to put this back into the context of our camera situation, let me unrotate my player here, and I'll get out of this orthographic view. And I'm going to get my game window pulled out so that you can see the scene view while the game is running. And I'm going to select my main camera. Now remember, the virtual camera here is just that. It's a virtual camera. It's basically providing instructions for the real camera. So I still want to look at the real camera in order to see the way it's oriented with the move handles selected here. So I'm going to run the game, and you'll be able to see, let me zoom out a little, you'll be able to see how the camera's orientation is changing as I use the mouse to change the orbit. And so our goal is so that if the player presses forward, they will move based on the blue forward vector of the camera. So because that changes as we orbit the camera, we need to rotate our input based on the camera's rotation, so that when you press forward, you always move what looks like forward. So right now you can see my camera's forward is sort of facing the world left. So if I press forward right now, if you look at the game window here, the player is going to not move what looks like forward in that camera view. It looks like he's moving to the right. And instead, we want it, when you press forward, it should look like you're moving forward. Like right now it does if I match the camera's orientation with the world orientation. All right, so that's the problem. In order to fix it, we're going to have to go into code. So let's double click on our rigid body character controller script here. So here you can see where we're getting our input. So this is every frame we're getting the X and Y input from the keyboard or the joystick or whatever, and we're turning that into a vector 3 that represents a direction in the world the player could move based on that input. So that's what input direction is. So this is the thing that's oriented based on the world that we need to transform into a camera relative orientation. And so since we want it to be based on the camera, the next step we need to do is get some information about the camera. So we'll start by getting the camera's forward vector. So you can do that by just typing camera.main, and that's always going to give you a reference to the current main camera. So just to be aware, by default, when you make a new scene in Unity, it will come in with the default main camera that has this tag main camera. And when you use camera.main, that's what it's going to be based on. So if you have a lot of things that are tagged with the main camera, this may not work how you'd expect, but by default it should work okay. And so one thing that's cool about Unity is we know everything has a transform. That's the only component that we know every game object has. But as soon as you have access to the transform, you can easily find its forward or its right. And so with those basic directions, you can do a lot of cool stuff. So we need to find the camera's forward. And I guess we should store this in a variable so that we can use it for something. So this is a vector 3, or if you think it's obvious that it's a vector 3, you can use the var keyword. In this case, it's obvious to me because it says vector 3 right here. Maybe it's less obvious here, so we could say we can spell it out, vector 3, and let's call this camera forward. Oops. All right. So now we have a variable that is set to the value of our camera's forward every fixed update. The next step we need to do is flatten this into a 2D space. So in order to understand that, let's just run the game again. I'm going to have my main camera selected and my move tool, and I want to make sure it's on local, and click in the game window so that the game picks up my input. Now, basically, take a look. When the camera starts to get high up, you can see that the blue move tool handle is sort of pointed down. And what we need to do is flatten the Y value of this, sort of bring the camera down to ground level so that it's still pointing the same forward direction, but in a 2D, on the same 2D plane that the player's walking around on. Like when we press forward, we don't want the player to move down into the ground. We want them to move in that same direction, except along the plane that they're walking on. So in order to do that, we're going to flatten this vector so that if the camera happens to be pointed up or down, we will bring it back down to the ground, but still maintain the forward direction it's pointing on this XZ plane the player's walking on. Hopefully that made sense. This is kind of confusing to describe. So the easy way to do that is just change the vector's Y value to 0. So now whatever the camera could have been up in the air, we're throwing that out and we're just flattening it down to be on a plane, XZ plane, just like our player. And I think what I'm going to do is rename this variable to make this more clear. So at first this was just the camera forward, which really you don't even need a variable for because you can always just type that. So let's call this the flattened camera forward. And if you rename a variable, you can notice that it gets this dashed outline. And if I hold Control and hit period, the quick actions in Visual Studio will pop up, and one of them is going to be to rename camera forward to camera flattened forward. And if I do that, you can see a little preview over here. What will change is it's going to change all the spots where we were using the old name to the new name, which is pretty handy. All right, so we fixed that. Okay, so now that we have the camera's flattened forward direction, we can use that to get a rotation that represents our camera's current rotation. So there's a function called quaternion.lookRotation, and you can see you pass in a forward vector, or a vector that represents something's forward, and it will give us back a rotation based on that. So we need to pass in the camera flattened forward, and we should store this somewhere. So this rotation that we're getting back represents the camera's rotation. So we can say camera rotation. All right. And this will be of the type quaternion, but in this case, it's clear we're getting a quaternion, I think. So we can just say var. And you can see that it's a quaternion. So in Unity, quaternions represent rotation, as opposed to what you might see sometimes, like degrees would be what we call Euler angles in Unity. And the reason is it avoids a problem called gimbal lock, which is confusing. And I'll make sure that we have a video about that to kind of explain it more. But anyway, all we really need to know is that this variable represents the rotation of our camera, or at least the rotation based on this flattened forward. And so now with this information, we can multiply that rotation by our input direction to get a new input direction that's based on the camera's rotation instead of the world's orientation. So let's make another vector 3. This one will be called camera relative input direction. And let's set it equal to the camera rotation multiplied by the input direction. And so when you multiply a quaternion by a vector, you get a new vector that's rotated this much. So we're basically rotating our input direction based on the camera's rotation. And so if we use this camera relative input direction as opposed to the regular input direction when we go down and add our force, we'll get the rotated camera relative movement that we're looking for. So let's just change this from input direction to camera relative input direction and save and test it out. All right, so I'm going to run my game. I'm going to drag the scene window over a little bit because now I kind of want to see the game view better. And so basically, no matter how you rotate, you would expect pressing forward to move forward, or essentially to move away from the camera, to move in the same direction the camera is pointing. So if you look actually in the scene view, you see the blue forward vector of the camera. If we can imagine lowering the camera down so that that's flat, that's the way the player should always be moving when we press forward, right along with that arrow. And you can see it's working. And the neat thing is, even if the camera moves so that it's pointed down or pointed up, it's still going to work. The player's still going to move on that flattened forward vector. Okay, so that pretty much addresses the camera relative movement problem. The next problem is we can't really tell which way our player's facing because he has no face. So once we can, we're going to notice that the player needs to probably face the direction they're moving. So that's what we'll work on next.